Recording it first. Those who have just joined, please have your notes as well as the paper that you drew the diagram on hand, because we are going to be drawing a diagram. All right. Okay. So let's take a look at this diagram of relief rain and orographic, or better known as orographic rain. What you see is a mountain. You see a water body near it, which is the ocean over here. Let me just make annotations. You don't have to make the annotations that I am doing because I'm just trying to direct your attention to certain things. So you have a water body over here, and then you have prevailing wind. Okay, so we are going to learn about prevailing wind in future lessons, but basically what prevailing wind is the direction that wind blows most often from. So it means that wind is blowing from that direction the most often, therefore it is the prevailing wind, most common. All right, so what we see in this diagram is that the prevailing wind blows over the ocean, and we know that water, when it's exposed to heat, it actually evaporates, right? So as the wind is blowing over the ocean, what happens is that it picks up the moisture that is evaporating from the ocean, and the wind becomes very moist. Okay, we all good so far? Are we all good? All right, if you're good, just give me a nod, okay, so that I know. Okay, so we know that there is this prevailing wind. It picks up the moisture from the water body that's over here, and then it meets a mountain. All right, so we know that it cannot pass through the mountains, right? Because the mountain is solid. Then what it is forced to do is that it is forced to rise up the mountain. Okay, Yen Kang, what happens to temperature when we go higher up, altitude?
Temperature decrease.
Temperature decreases, right? So as the temperature, as it rises, it cools down because temperature decreases. And then Darwin, can you tell me, when temperature decreases, what happens to relative humidity?
It increase.
It increase. Okay, good try, but okay, let me just correct the misconception. So remember, we are a parcel of air, for example, is occupying, let's say this water bottle is half full, okay? And this is air at a particular temperature. So when air cools down, the air particles actually occupy less space, right? So then the RH, wait, you said the RH will increase, is it? Yeah, you're right, actually. My bad, sorry, I heard the wrong thing. So RH will actually increase because the space becomes smaller and the water vapor actually occupies a larger space. Okay, so that's what happens. So as we have learned in our classes, as it cools even further, it reaches dew point temperature. One thing, when dew point temperature is reached, what happens? So dew point temperature is the temperature at which what happens? What process?
Condensation.
Condensation. So water vapor become water droplets, and when you have your condensation nuclei, you get your clouds. Okay, so the clouds through the water droplets through coalescence results in clouds. Then what happens when the water droplets become too heavy? You actually get your rain here. Okay, so what I need you to focus on now is, don't look at this other side first. We will take a look at this other side later. Just understand what's happening on the left-hand side of the diagram first. Okay, so I know you guys have blanks in your student handout. I'll just let you copy this first, and then I will explain further. But most of it has already been explained. If you are done copying, can you give me a thumbs up reaction using the reaction button on Zoom so that I know? I know there's quite a lot to copy, so make sure you have everything written down first. All right, Corel is done. Just give you a few more seconds. See what happening. Tessa is entering the room. Hi Tessa, please have your notes and the paper that you drew the diagram on yesterday, okay? Felicia. Okay. Okay, Tessa and Felicia, you just listen to my explanation first. Let me just go through the explanation for a bit. And then with regards to what you need to copy, later when I end the class, I will just stay here for a bit and let you copy what you need to copy on what you have missed out, okay? So ladies and gentlemen, let's take a look at our explanation over here. So when you are writing your explanation for your examinations, this is the level of detail that you are expected to produce when you're trying to explain how a particular type of rain forms, okay? So like what I mentioned just now, relief rain is formed when there is a prevailing wind approaching highlands. From a highland refers to your mountains, from a water body. So this was our ocean. Okay, so the moist onshore wind is forced to go up the windward slope of the mountain. So let me just move back to this diagram. The windward side of the mountain is basically the side of the mountain that is facing the prevailing wind. So that is how you make sense of it. Windward means it is facing the prevailing wind. All right. So as it is forced up to go to the mountain, the rising air begins to cool, relative humidity increases, and it reaches dew point eventually as it rises even further. That is what we have here. And then the water vapor condenses into clouds around the condensation nuclei. And when it's too heavy, it falls on the windward side as relief rain. All right, everyone good so far? Gerard, welcome to the class. Please take out your notes and the paper that we used yesterday. All right, so ladies and gentlemen, that is basically the formation of relief rain. What I need you to do now is take the paper that we were drawing on yesterday. We're going to start drawing the diagram, okay? Right, so just look up, okay, wait, just give me a thumbs up if you already have the paper in front of you so that I know that I can move on. Thumbs up reaction, okay? Okay. All right, so what you're going to be seeing on screen are different steps the different steps of drawing the diagram. So I do not have a tablet with me right now. Therefore, I already have a pre-drawn step-by-step guide on how to draw the diagram. Just follow along with it and practice how you draw the diagram step by step. All right. Okay, so our first step, I would like you to draw this. So you need to draw your highland or your mountain, and then you need to draw your ocean. So this is our first step. To my people who just entered the Zoom meeting, please have the paper that you were drawing on yesterday on hand. We are currently drawing the diagram. Okay, so once you have drawn that, what is the next step? We will have to annotate the prevailing wind. So I want you to draw an arrow and then on top of it label prevailing wind. So this is where the prevailing wind is coming from. All right, so after you have drawn the prevailing wind, remember what happens to our next step. The prevailing wind is moist, the prevailing wind is warm, but it meets a mountain, and therefore it is forced to rise. It is forced to rise the windward side of the mountain. So remember, the windward side refers to the side that is facing the prevailing wind. So by the look of your faces, you're still writing. Let me just give you a few more seconds. Right, I'm sorry to sound like a broken record, but I have to make the announcement to the people who just entered. Please have the paper that you were drawing on yesterday. We are drawing the diagram. All right, so I'm now going to move on to the next step. After the moist, warm air is forced to rise the windward side of the mountain, the rising air begins to cool further, and this leads to air reaching dew point temperature. Because our relative humidity increases, eventually it reaches the dew point temperature. Okay, I know there are clouds there already. The next step will actually be describing how the clouds actually form. All right, and then the next step, water vapor then condenses into water droplets because it has reached dew point temperature. Clouds then begin to form. Water droplets fall as rain when they are large enough. All right, so this rain actually falls on the windward side of our mountain. All right, so after the clouds have formed and it has rained, can I get you to show your beautiful diagrams to the camera so that I can see? Or if you're not done, I'm going to give you 20 more seconds to just finish writing this, okay? All right, so I assume that you guys are done. If you're not done, okay, you're not done. Okay, I'm so sorry. Okay, I'll give you a bit more time to finish writing. Darwin, we good? All right, solid. Okay, so now, ladies and gentlemen, I will need you to show me your beautiful diagrams on screen. Oh, wait, no. Yeah. Can you just show me your diagrams? Okay, I see. One thing's one. Darwin, where's yours? Closer, closer. Okay, a bit small, but yeah. Thank you. Cheryl, where's your diagram? A bit closer. Okay, wonderful. All right, wonderful, wonderful. Okay, big sun. All right, okay. So thank you very much. You can put your diagrams down. So remember in class yesterday, good job guys on the diagram. So remember in class yesterday, I showed you this map where one side was green, one side was brown, and said that, there was something about the mountain that causes the other area to be very dry. Okay, so let me just show you this picture. Yesterday we talked about area A and area B, and we were trying to find out why this is so. Okay, so now I'll give you a second part to the diagram. One more thing you need to add. Okay, so because all the rain has already dropped on the windward side. Okay, you listen to me first, then I'll tell you to copy. Okay, so because all the rain has already fallen on the windward side, when it overcomes the mountain, when air overcomes the mountain and goes down the leeward side, it is already dry. That is the reason why the other area B over here is so dry. It is because all the moisture has fallen as rain on the windward side. This is known as the rain shadow effect. Okay, so just copy down the text and the arrows here. This explains to you why the other side of the mountain is dry. Zanrui has left. Okay, someone please check on her after this class, okay, and see whether she's okay. Okay, I'll give you 30 more seconds to just make this annotation. All right, okay, so I will now move on to the next part where I will be telling you why you need to know this. Okay, so we learn about how to explain how relief rainfall is formed, but it's also important to actually understand what happens on the leeward side, the drier side of the mountain. Because at times you may actually get questions asking you, why is the amount of rainfall on the leeward side of the mountain extremely low, for example? So you see two command words here, describe and explain. If a question asks you describe, the question that you actually need to answer is what? Tell me about the rainfall, for example. And then when you are required to explain, the question that you're answering is actually why. Why is whatever that you have described in the described portion happening? Okay, do you guys have any, can I just check one thing? Does this slide have any blanks?
Yeah, there's a few.
Okay, so I'm going to give you a bit of time to copy down what you see here, okay? Ainsley, are we done? Are we good?
Yes.
Are we good? You're
Yeah.
good, you're done? Cheryl, are you good? You're done. Okay. So I'm going to move on to the next part. Hey, before I move on to the next part, I will give you the explanation. I'll just unpack this for you. Okay. So we know from my explanation just now is that there is this on the leeward side of the mountain, there is very little rain because of this rain shadow effect, or there's a rain shadow area. Okay. And it's so dry that it becomes a desert. So why does this happen? It is because most of the water vapor already condensed on the windward side of the slope and has fallen as rain on the windward side of the slope. So over here, when it overcomes the mountain and it sinks down, the temperature rises and relative humidity decreases. So the air is already dry. Basically, when it goes down the leeward side of the mountain, air is already dry and you don't actually get any rain. All right, very little rain, in fact. Okay, Ainsley, we're good. Understand? All right, wonderful. Okay, so now I need you to do a little bit of an activity for me to check whether you understand the different parts of relief rainfall. So I'm just going to call on some people to provide me answers for the different steps. Okay, if you can, do not refer to your notes so that you can check your understanding. Okay, so let me just start off with my first volunteer. You're just going to say out to me, okay, because initially I wanted to use the post-it function, but there isn't a chat in my Zoom. Okay, so first volunteer, I want Big Sun Rai. Big Sun Rai, what do you call A and what do you call B?
Rainy windward side and dry leeward side.
Excellent. You pick the next person.
Darwin.
Darwin, I already called you, so you're gonna pick the next person.
Noel.
Noel, can you tell me the step that happens at step 1? Noel, are you with me? Okay, it seems that Noel, is your mic muted?
Sorry.
Yeah,
Sorry,
yeah.
my mic wasn't there. Yeah, I just plugged it in.
All right.
The moist from the warm water ocean rises.
Okay, so the
to the windward
moist,
side.
warm air rises, right? The prevailing wind, warm, moist air rises. Okay, so then correct. So you pick the next person.
I don't know. You can just call.
Okay, I call. I will call Mr. I will call Hong Yi. Hong Yi, are you with me?
What?
Okay, Hong Yi, what happens at 2?
Air condense. reach dew point temperature, then condense.
Okay, so it reaches dew point temperature and then it condenses. Very good. I like that you corrected yourself. Okay, then can I get Katerina? Katerina, what happens at 3?
Water vapor condense into water droplets
Mm-hmm.
and fall as rain when they are large enough. Yeah.
Okay, Katerina, I'm going to challenge you a bit more. Does this rain fall on the leeward side?
Sorry?
Does this rain that you just described fall on the leeward side?
No.
No, it falls on the which side?
A.
A, which is the what side?
The rainy windward side.
All right, yes. Okay, so in your exam, you can just write windward side. Don't need to write rainy, okay? But here, I'm just using an adjective to describe it. All right, ladies and gentlemen, that is how you explain relief rain. In the next lesson, we're going to be covering air pressure and winds. So this topic is a bit complex, but don't worry. Anyone has any questions or confusions that they would like to clarify with me thus far in relation to weather and climate? You can do so now since we have a bit of time. I'm going to wait 30 seconds. If there's no questions, I will move on to my next slide. All right, no questions. Okay, if there are no questions, can I just trouble you to help me out a bit? Okay, so I want to make lessons engaging for you. I want to know what you guys like to do. I want to know what kind of activities you like. So can you just use your phones and then scan this QR code and just help me answer the Google form here so that I know what my students what kind of activities that I like. Because if I just stand in front of you and lecture you for 1 hour, maybe you don't like that. Maybe you want more activities. So let me know what you like. Okay, so with that, thank you, ladies and gentlemen, for attending today's class. I wish you a very, very good weekend. And yeah, have fun. All right, you may leave the chat. Thank you, guys.
Bye.
Bye. Hi, Chloe. Who is that?
Okay, thanks.
Thank you. Bye-bye. Have fun. Have a good weekend. Noel and JL, you may leave the chat already. Okay, if there's nothing else, I'm gonna end it. Okay, thank you guys.